Hello everyone and welcome. By default, the communication between Kubernetes services and their clients are not encrypted. Everything is in HTTP and plain text. So that imposes a huge security risk for the clients that are coming from outside the Kubernetes environment. In this episode, we will take a look at how we can secure those communications through TLS Ingress, Cert-Manager, and Let's Encrypt certificates. We'll start off by taking a quick look at Kubernetes services and service type, such as node port and load balancer, and some of disadvantages of consuming those services directly without going through an ingress. We'll then introduce Kubernetes ingresses and different types of ingresses that Kubernetes support. We'll then next take a look at Cert-Manager, and Cert-Manager allows us to automatically acquire certificates from certificate authorities such as Let's Encrypt. We'll then deep dive into ACME Challenge Protocol, and that is the protocol that Cert-Manager uses to safely and securely acquire certificates for our needs. Then we will take a look at Let's Encrypt certificate. And finally, we'll take a look at TLS Ingress type, and that is the type that we will be using to secure our services. For the demos, we will be using Cert-Manager and Let's Encrypt to acquire TLS certificates required by our ingresses. And finally, we do a lot of demos. We'll demo how to create different types of ingresses, how to set up Cert-Manager, and how to configure it to acquire certificates for our TLS needs. Hope you can join me. Let's quickly review how Kubernetes services work and how they're exposed to the clients. Let's assume that we have a Kubernetes cluster that consists of a single master and a couple of nodes, node 1 and node 2. Hopefully each server has a firewall. So this firewall is for master, this one for node 1, this one for node 2, and also a perimeter firewall that protects our intranet from intrusion from outside environment or internet. Within the cluster, let's assume we use traditional kube proxy and IP tables. So these are the default way of load balancing our services. When a call comes in for a service, it goes to the kube proxy. The kube proxy then forwards a request to IP tables that then at random picks one of the pods that are behind this, and then pod will respond. If you're using Cilium, Cilium does not use kube proxy. It uses what is known as Cilium agent, and instead of IP tables, it uses EVPF-based tables, which are a lot faster. But let's say for our example, we use kube proxy and IP tables. Let's assume that now we deploy an application called app1, and let's assume we have two pods that service that app1 and app2. Although we deploy this application, but this is not really very useful because client can really access it unless they know the IP address of the pod and the port number. However, to make that more useful, we need to define what is known as a service. So when we create a service, in this case we call it my service 1. The service Kubernetes will create what is known as cluster IP, which is an internal IP address to the cluster. So as long as our clients are all inside the cluster, they can call this IP address directly, and then it goes through the same process of go to the IP tables and then get load balanced. However, what about the clients that are outside the cluster in our intranet environment, or even from the internet that they need to consume the service? So in order to make that possible, traditionally when we create a service, we declare the type as node port, and what it does is Kubernetes will open a port, will create a port. It's just a random number, but you can also specify to create a specific port number, and then that will allow the clients to come in. However, in this case, we need also to open firewall rules that will allow traffic into our environment. So when the client will need to then call the IP address of each one of the servers, and then use that port in order to get inside our cluster, and then go through the IP tables and get served. So again, we need to create a rule on each node that will allow the traffic coming in for that server and that port number. And for our external client, we also need to open a port or define a rule in the firewall that will allow coming in for allow traffic to all the nodes that are part of our cluster, and also allow to go through that port. If we deploy another application, or by the way, if you are in the cloud environment, then you can, instead of node port, you can declare a load balancer type, which it will also create a node port as like before, but also it creates a load balancer which is publicly available from outside. So you can then, the clients can come in either from the internet or from intranet or internet and through consume our service. Let's assume that we also deploy another application called app2. Then we need to do the same thing. We need to create a cluster IP, and then create a node port, or if we are in a cloud environment, we can also create a load balancer that again will create a load balancer, will expose that, and it will create a corresponding node port, and then the client then can come in and consume the service. So as you can see, as we increase our services, then we'll have a lot of firewall rules that we need to create, if we both on the server and also for the clients that are coming from outside. So this probably gets out of hand. Then our firewall becomes like Swiss cheese. There's a lot of holes in it. So this is where Ingress comes into play. So rather than exposing these ports all the time, we can create a single entry, one or more, a lot fewer than creating node ports for each service. We can create a single ingress or very limited number of ingresses. That the ingress will allow the traffic when they come in. We can create rules for that, and then depending on what service they're calling, they go to different services. So that makes management of services, especially coming in from outside the cluster, a lot easier. And that is something that we're going to discuss next, what ingresses are and how they work. Ingress exposes HTTP and HTTPS routes from outside the cluster to services within the cluster. Traffic routing is controlled by rules defined on the Ingress resource. Ingress can also provide TLS termination. In order for Ingress resource to work, the cluster must have an Ingress controller running. There are a number of Ingress controllers are available. For this video, we will be using nginx Ingress controller. Ingress rules. Each HTTP rule contains the following information. An optional host. If no host is specified, the rule applies to all inbound HTTP traffic through the IP address specified. If a host is provided, for example, foo.bar.com, the rules apply to that host. And we'll go through that when we get to the demo, how that works. A list of paths, for instance, /test path, each of which has an associated backend defined with the service name and service port number. Both the host and path match the content of incoming requests before the load balancer directs traffic to the reference service. Again, don't worry about that. We'll go through that during the demo to make that more clear. A backend is combination of service and port names. There are different ingress types. The simplest one is called simple fan-out. A fan-out configuration routes traffic from a single IP address to more than one service based on the HTTP URI being requested. So let's take a look at this pictorially. Let's say we have two services, one called My Service 1 that is listening on this port, and these are the pods behind that. And then another one called My Service 2. This is the port number that is listening on. Again, these are the pods behind that. We want to specify that we want to create a single ingress that will manage both these services. So if the user specify /myservice1, the request should be routed to myservice1. If they specify /myservice2, the request should be routed to the service. So obviously we have a load balancer here, and the client calls into that load balancer, and then the load balancer is managed by Ingress controller. In our case, would be nginx. So let's see how we can implement such an ingress. So this is a quick overview of the YAML that we need to create. We need to specify the kind, in this case is ingress, and then specify under metadata a name for it, whatever name you want to call that. We also need to add annotations, and specifically, we need to specify what type of ingress controller we are using. So we need to specify kubernetes.io/ingress.class : and the name of the ingress controller. In this case, we are using nginx, but you can use a different one. So as we mentioned earlier, there are different types of ingress controllers you can choose from. And then under spec section, we have rules for this ingress. First, we need to specify the host name for it. So normally this host name will correspond to the IP address of the load balancer. And then we need to specify, next we need to specify the protocol, in this case HTTP. Then we need to specify the paths. And also we need to specify the type of path. So let's take a look at this more closely. So there are two types of path. One is called exact, and it matches the URL path exactly, and with case sensitivity. So if we specify /myservice1, and then the type is exact, then they have to type exactly myservice1 /myservice1 or exactly myservice2. However, if we specify prefix, like we done here, it gives us more flexibility. Prefix matches based on URL path prefix split by /. Matching is case sensitive and done on a path element by element basis. A path element refers to the list of labels in the path split by / separated. Basically what it means that when the request comes in with whatever paths the user passed in, the path is split by /. It could be a number of them, / and /. And then within that, there are elements that it checks to see if they are valid or not. So let's take a look at it to make it more concrete. For example, let's say the path, like we specify here, is myservice1. If the user specifies /myservice1 and an extra /, does it match? Yes, because this / when it's split and this into two different elements, one is /myservice1 and the other one nothing, because there's nothing in here. So that part is ignored. So that's valid. Again, the same thing, the path /myservice1 we specified here. If the user specified /myservice1 /info, does it match? Yes, because it includes the the one that we are looking for, slash my service one. And this one, slash, is a different one. It is considered as subpath, and this is valid. And the last example is, let's say we specify slash my service one foo. Although it includes my service one, but it's not exactly slash my service one. It's got these elements that are not part of the desired path. And in this case, it doesn't match. So this is a quick overview of how path types work. But there's more to it. And I encourage you to go ahead and look at them on your own. But this is good enough for us to continue. And then we specify, obviously, the path that we want. And then under back end, as we mentioned earlier, is really we are specifying the service. So what is the service behind this? For the first one is my service one. This is the name of the service. And also we need to specify the port that is service listening on. In this case, it is port 80. And then the other option is slash my service 2. Again, we specify prefix. You can specify exact match. If you don't have anything that you want to pass after, like my service 2, we can specify exact match. Again, we specify the back end, and below that, the service that is behind that. In this case, is my service 2, and is listening on port 80. Another type of ingress that we can leverage is called name-based virtual hosting. And they support routing HTTP traffic to multiple host names at the same IP address. So let's say we want to expose, again, our service 1 and service 2 through an ingress, but rather than using simple paths as separated between these two, we want to actually specify different host name for each one of those services. So if the user specify in the host header service1.mycompany.com, we want the request to go to my service 1. And if they specify service2.mycompany.com, we want to be routed to this service. So let's take a look at the YAML that would implement such an ingress. So again, the ingress, the kind is ingress. Again, we need to specify a name for it, and then also what type of ingress, as we specified before, what ingress controller we are using. Again, we're using nginx. And then under spec and the rules, we have so we are now distinguishing by host. So we have two hosts here. The first one is called service1.mycompany.com, and then we specify the protocol, and then we can also specify paths. We specify paths. Again, we can use the prefix or match, and then in this case, path is equal to slash. So there's nothing after that, which means that it accepts all the paths that are coming. If you specify this host, then any path that we specify, it always calls my service 1. You could be more specific if you want to, but for this case, we just say like any, if they specify service1.mycompany.com, regardless of what path they specify, we want to be forwarded to this service. Again, we specify the back end, which really we are defining the service, the name of the service, and the port number that it's listening to. And similarly, we do the same thing for myservice2.mycompany.com. If you recall earlier when we talked about Kubernetes services and how they work, we also walked through a simple case where we had a couple of services that we wanted to expose them to the outside world. Another time that we hadn't talked about ingresses yet, our choices were either use node port service if we are deploying our service internally, that is our Kubernetes environment is hosted internally, or we could use a load balancer service type if we were hosting it on the cloud. However, we talked about the disadvantage of that method, because every time that you deploy a new service, then you have to adjust the firewall and allows traffic into that service because they will be using a different either port or IP address. And in case of the cloud, if your infrastructure is in the cloud and every time that you create a load balancer type service, then they create a load balancer for you. However, it's not free. You have to pay for it. So a better option is to use an Ingress. And that is the topic of our upcoming demo, how we can change our method from either a node port or load balancer into actually using an Ingress. So this is the agenda for the upcoming demo. First, we talk about a requirement that's needed, especially if you're doing it on your, you're learning and you're doing it in your own home environment, then you need a load balancer. So in order to use an Ingress, you need to have a load balancer. And there is one called Metallb, which is specifically can be used by Kubernetes. And it's actually very easy to set up. We'll walk through the how to set up that environment so you have a load balancer. So basically, load balancer will load balance between your nodes. And then we'll talk about walking through setting up an Ingress controller. In this case, we'll be using nginx, so how to set up nginx controller. And finally, we'll create an Ingress for our services. So as mentioned earlier, Metallb is a nice way to set up a load balancer. This is a software load balancer to test your environment. So setting it up is pretty straightforward. You just need to install it from this location and just say kubectl apply -f, and this is the URL that you want to get it from. And then wait for a few minutes, and there are a number of things that will be installed. I've already installed that, so I'm not going through the process again. But there are a number of things, such as there's a controller here, there's a speaker, so all should be ready. There's a service, daemon set, so you want to make sure that all in ready state and running before proceeding to the next step, which is the next step is to define an address pool. So as you define services or ingresses, then the new IPs are needed, and you need to define where to get what pool to get it from. And this really depends on your environment. And this is my environment. I'm in the 192.168.0 subnet, but just make sure you change that to whatever your subnet is when you're testing it at home or wherever you are. So this is the first part. The second part, also, we need to specify another YAML, which is this time the kind is at a L2 advertisement. So because I'm assuming that all your servers, all your nodes are in the same L2 domain, that is, there are no routers between them, then you can use L2 advertisement. So basically what it means is that servers advertise their existence to other servers. So if this server wants to communicate with the other server, it knows how to get there. So basically that's what we need to do. So again, this is very easily set up. Once you set up that, then we can then move on to the next part, which is setting up nginx controller. So next we are going to install nginx controller, and that is also pretty straightforward. We need to download the YAML from this location. And then we need to make a change here because just now we set up our load balancer. So we need to make a change in that YAML. So we need to go under kind service. So we need to find the service part, and we need to change the type from the default in the YAML is the node port. We need to change that to load balancer. So I'll provide this YAML as part of the course download, so you can go ahead and download, so you don't have to modify anything. So just run this, apply kubectl apply -f, and then whatever the name of the YAML is. So that will going to set up the nginx controller. So we want to make sure that everything is ready before going any further. So kubectl get, we need to look at all the pods, make sure that they're installed. And then it will create a namespace called Ingress-nginx. So let's go and see where everything is, and everything looking good. So you want to make sure that the controller is in running state and the other one says complete, and they shouldn't be in ready state, but it should say completed. So now that we've set up the prerequisite, we have the load balancer, and we also have the nginx controller. Next, we can do some testing. So the first thing that we want to do is to get the IP address of the Ingress controller, because that's how all the traffic going forward should come through that Ingress, and then the Ingress will then forward the request to whatever services that are behind our applications. So in order to do that, we need to extract the IP address. And so this is how we do it. Let's just go through it one step at a time. So the IP is included in the service, but we need to do a little bit of magic in order to get that. So let's go through that. First of all, we need to specify kubectl minus n. So the namespace for nginx controller is ingress-nginx. Then you need to take a look at the service get service, and the service name is that's what it's called when the nginx controller is created. The service name that is assigned to it is called ingress-nginx-controller. And then we want to deploy or display this result as JSON path. And then in that, we are looking at .status.loadbalancer.ingress. So that basically that command will result in this. So let's go ahead and run that. And we'll see that it gives us the IP colon 192.168.0.90 in my case. But we want to get rid of everything else, like the brackets and the IP and the colon. That's why we pump that into this command to basically a little bit of shell to get rid of those things that we don't want. So let's go ahead and do that. So now what we have is Ingress IP address would be just this part, the IP address, actual IP address of the controller. Now we are deploying, basically we are implementing the what we talked about in the presentation. So we have two applications, one is called app1 and the other one app2. So the first part, we do a deployment. So kubectl create deployment, and we call that app1, and this is where the image is coming from. This is basically a hello world application. We also going to expose that is create a service. So kubectl expose deployment app1, and we call that service my service1, which will be listening on port 80, and we will forward the request to port 8080. This is where the service which is installed in pod will be listening on. So let's go ahead and do that. So that's done. Do the same thing for app2. Again, this is another simple hello world application. So let's do that. And we also expose that, and we call the second service my service2. So let's go ahead and do that. Now those are exposed. So if we do kubectl get svc, so you can take a look at my service1. So we see that it's listening on port 80, and this is also listening on port 80. So we don't want to go through the cluster IP because those are only available from the client inside the cluster. So we want to create an ingress to make those services available to the client that are coming from outside the cluster. And this is basically what we do. The first example is fan out ingress. And this is very similar to what we saw earlier in the presentation. So the kind is ingress. We give it a name, and then we define a host. So we have a single host for this application, for this Ingress, and then the path either /myService1, and this is how they are served by myService1, and then or /myService2, and they will be served by myService2 service. So let's go ahead and run this. Now we have that also created. So let's do some testing. So curl -- header. So we need to specify the header, and the header would be the host name, mycompany.com. That's we specified up here. And then we call the service HTTP, and then Ingress IP, so that would be the IP address of the Ingress controller, and /service1, myService1. So why do we need to specify the host in this case? Because we are not running it from browser. If you want to run this from browser, you need to create an entry in the DNS, your local DNS, mycompany.com, and give it the IP address of the Ingress controller. Let's go ahead and run that. And this is the example that is coming from myService1. So hello world and version 1 and the host name. We do the same thing now for on line 47. We're going to call now myService2. Let's go ahead and do that. And this is again another, the message is coming from the second service. Basically, this is a bootcamp sample application. Okay, so that was the simple fan out. So let's go ahead and delete that. And we reuse the same application and host, or this time, or services in this, but we are going to create a new Ingress, and that's name-based virtual hosting Ingress. So we talked about that again earlier. So again, the kind is Ingress, and then over here, now we have two separate hosts. So one is called service1.mycompany.com. If that is in the header, then it will send a request, look at the path. In this case, all paths, so / means all the paths. And then within that, then this will be served by myService1 service. And similarly, if they specify my service2.mycompany.com, then that will be serviced by myService2 application. So let's go ahead and create this. Okay, now let's go ahead and test that. So first one, curl -- header. The host is service1.mycompany.com. So this is the first host that we specified up here. Let's go ahead and run that. And again, we get the result from myService1. And you can do the same thing now from service2. So curl -- header, and then the host would be service2.mycompany.com. And then I'm going to do that. And this is, we get the same result back as we had earlier. The third Ingress type is TLS. TLS allows securing an Ingress by specifying a secret that contains a TLS private key and certificate. The TLS secret must contain keys named TLS.crt and TLS.key that contain the certificate and private key to use for TLS. Referencing this secret in an Ingress tells the Ingress controller to secure the channel from the client to the load balancer using TLS. We need to make sure that TLS secret we created came from a certificate that contains a common name, or CN, also known as fully qualified name, or FQDN. For example, https:/example.food.com. So the name must adhere to the FQN, or fully qualified name. The Ingress resource only supports a single TLS port, 443, and assumes TLS termination at Ingress point. Traffic to the service and its pods is in plain text. So again, the TLS, or encryption only, is between the client up to the load balancer, and everything from that point on into the Kubernetes environment is in plain text. So let's take a quick look at how we can create an Ingress type TLS. So the kind still is TLS, nothing really, Ingress, nothing has really changed. I mean, we still need to specify a name for it. We also still need to specify under annotations what Ingress controller we are using. In this case, we are using nginx. And the spec, this is a new section called TLS. And we need to specify the host name, and this has to be a fully qualified name. And this needs to match exactly as the host down here. So these two have to match, and this has to be a fully qualified name. We also specify the secret name. So again, the secret specifies, will contain the certificate and its private key. Obtaining certificates manually and also dealing with the expiration dates, which could become a huge problem if you have many services handle thousands of services and they have certificates and they have an expiration date, and manually, keeping track of when they expire is a lot of work. And that is why a lot of companies that use Kubernetes, they're adopting Cert-Manager that we're going to talk about next. Cert-Manager adds certificates and certificate issuers as resource types in Kubernetes clusters and simplifies the process of obtaining, renewing, and using those certificates. It can issue certificates from a variety of supported sources, including Let's Encrypt, HashiCorp, Vault, and Verify, as well as private PKI. It will ensure certificates are valid and up-to-date, and attempts to renew certificate at the configured time before expiry. So these are some of the benefits that Cert-Manager brings to the table. So let's take a look at overview of how that works. So we have Cert-Manager installed in our Kubernetes environment, and these are some of the providers, supported providers such as Let's Encrypt, HashiCorp, Verify. It could be also private PKI infrastructure. When you want a certificate, you specify which one of these providers you want to certificate from, and Cert-Manager will get that certificate on your behalf. It will also create a secret based on the certificate and its private key. And you can also request a different certificate from a different provider. For instance, the next one could be from HashiCorp. It will go through the same process, obtains a certificate, and create a secret. So it is very flexible. As we just mentioned, Cert-Manager is able to obtain certificates from an issuer on our behalf. So it does that through using a protocol known as Automated Certificate Management Environment, or ACME for short. ACME is communication protocol for automating the issuance and domain validation procedures, allowing the automated deployment of public key infrastructure without user interaction. It was designed by the Internet Security Research Group for the Let's Encrypt service. ACME used primarily to obtain domain-validated or DEM certificates. DEM certificates do not specifically identify or validate the organization using their certificates, but rather validate a request against the domain registry. In contrast, an organization-validated or OVM certificate identifies the organization and validates the identity against a business registry. The two main entities in ACME are the ACME client and the ACME server. The client uses a protocol to request certificate management actions such as issuance or revocation. A client may run on any server that requires trusted SSL certificates. The server runs at the certificate authority, and responds to client requests, performing the requested actions if the client is authorized. So in the Kubernetes environment, the Cert Manager becomes the ACME client, and those issuers, such as Let's Encrypt or HashiCorp, are the ACME servers. And the communication between the client and the server is based on JSON message over HTTPS. The ACME issuer type represents a single account registered with the ACME certificate authority server. When you create a new ACME issuer, Cert-Manager will generate a private key, which is used to identify you with the ACME server. Certificates issued by public ACME servers are typically trusted by clients' computers by default. In order for the ACME CA server to verify that the client owns the domain or domains a certificate is being requested for, the client must complete challenges. So let's say I am requesting a certificate for a domain called mycompany.com. So for the CA issuer, the certificate issuer, will need to verify somehow that I actually own the domain mycompany.com, and that is how the challenge mechanism occurs. So again, this is to ensure that clients are unable to request certificates for domains they do not own, and as a result, fraudulently impersonate another site. As detailed in the RFC 8555, Cert-Manager offers two challenge validations, HTTP 01 and DNS 01 challenges. We can configure Cert-Manager to either use HTTP 01 or DNS 1 challenge. HTTP 01 challenge, this is the most common challenge type. And basically in this challenge, the ACME CA server, that is the issuer, gives a token to Cert-Manager and asks it to copy it to a well-known location under HTTP, the domain name, and this location over here. And then the file contains a token plus a thumbprint of our account key. And then Cert-Manager informs the issuer that this is the file is located here. And the ACME server then tries to retrieve that. If it's successful, then the certificate is issued. In the DNS 101 challenge, we need to prove that we own the DNS for our domain name. And that is done, this is similar to HTTP 01 challenge in that the ACME CA server will give Cert-Manager a token, but rather than copying that token into a specific location on a file server, we need to copy that into our domain name DNS record. And then the ACME server will verify that the name, the token is there. This is a little bit more complicated than HTTP 01 challenge, but it is useful in situations where the ACME CA ACME server is not able to directly interact with the web server at our domain name. We covered a lot of topics concerning TSL Ingress, TSL certificates, and ACME challenge response. Let's see how everything works together. Let's say we have a Kubernetes environment and we have installed Cert-Manager. Now we want to leverage Let's Encrypt stage issuer and start requesting certificates. So the first thing that we need to do is we need to define this issuer in Kubernetes. And this is how we do it. We create a YAML. The first thing that we need to specify is API version. And this is cert-manager.io-v1. So that was v1 at the time of this recording. I need to specify kind. The kind could be either cluster issuer or just issuer. So when we specify cluster issuer, then this issuer will be available at the cluster level. If we just specify issuer, then we need to specify a namespace where that issuer will be available. We'll then need to assign a name to it. And under spec, we need to create a section called ACME. Let's go through that section. So the first thing that we need to specify is the server, so the URL to the Let's Encrypt stage environment. So that's what the issuer will be. And we need to specify a valid email address in case the issuer needs to contact the requester. And then under private key secret reference, so basically what happens is when this is submitted, Cert-Manager will create a private key that identifies itself to the issuer. So this is where that secret name is. And then we specify the solver. So basically this is, we are specifying how we answer to the challenge issued by the issuer or ACME CA server. So we will say that we're going to use HTTP 01 rather than DNS 01. And then when they need to define what type of ingress controller we're going to use, so you're going to use nginx, and also what kind of service will be created, and that will be in node. So basically what happens when the challenge is issued by the issuer, then on the fly, Cert-Manager will create an HTTP server, and then we'll modify the ingress to allow the Cert-Manager or the issuer to call into the environment and put that token that we talked about. We'll go through that again. Once that's submitted, then we know how to manage the challenge. The first thing is to actually request a certificate. And then the API version, again, this is the API version at the time of recording, and the kind is certificate. We specify a name for it. We also specify a secret name. So when the certificate is successfully retrieved, Cert-Manager automatically create a secret for that certificate because we need that for TLS. And the DNS name, so that will be the name on the certificate. In this case, would be mycompany.com. And then we need to specify what issuer. So again, basically we are referring back to the certificate, to the issuer that we defined earlier. And we call that Let's Encrypt dash stage. And the kind that we defined for it was cluster issuer, and this is the group. So basically, this basically refers to the issuer we defined earlier. So once that is submitted to API server, Cert-Manager will create a key pair for the certificate and then submit that to Let's Encrypt stage issuer, and it will specify the domain name. So it will be the certificate, the name of the certificate will be mycompany.com. It also send the key pair for the certificate to the issuer. Then Let's Encrypt will challenge the Cert-Manager, and it requires two things. One, it sends basically a text called a random text called nonce. It says you need to sign it with the private key, your private key, and also copy, send the token again a random series of text, and copy it in this location. So http mycompany.com /.bell-unknown ACME challenge. So that is then sent to Cert-Manager. Cert-Manager on the fly creates an HTTP server. It will also modify Ingress to allow traffic through the load balancer and into the server we just created. It will then copy that token that was received from the issuer and put it in this location requested by the issuer. It will then get that, send that text that was issuer sent, and then uses its private key to sign it and send it to the issuer. So the issuer will verify the signature on this text. If it's valid, then it goes through it calls this URL, http://mycompany.com, and the request goes through the load balancer, through Ingress, and then comes to the server, and then retrieves, tries to retrieve this token. So if it all goes well, then this is at that point, then a certificate will be issued for the requester. Let's Encrypt is a free, automated, and open certificate authority, or CA. Run for the public's benefit. It is a service provided by the Internet Security Research Group, or ISRG. During the development or testing, it is recommended to utilize Let's Encrypt's staging environment instead of production API, as there are no limits to the number of requested certs. Now, as far as the limits for production, the main limit is the certificates per request domain, 50 per week. A registered domain is, generally speaking, the part of the domain you purchase from your domain name registrar. For instance, in the name w.example.com, the registered domain is example.com. Or another example, in new.blog.example.co.uk, the registered domain is example.co.uk. They use the public suffix list to calculate the registered domain. Exceeding their certificates per registered domain limit is reported with the error message, too many certificates already issued, possibly with additional details. You can combine multiple host names into a single certificate. So a way around this limit is to combine the host names into a single certificate, up to a limit of 100 names per certificates. But they recommend that for performance and reliability reason, it's better to use fewer names per certificate whenever you can. A certificate with multiple names is often called as SAN or SAN certificate, or sometimes as UCC certificate. In the upcoming demo, we will be creating a TLS Ingress that leverages Cert-Manager and Let's Encrypt Certs. Let's walk through my environment first. So I'm showing here my home network as intranet, and there's a router and firewall that sits between my home network and the internet. And this router has been assigned a public IP address by my ISP provider, which is Comcast, and also assigned it a name. So this router has a name, and that name is registered in the public DNS. So I'm going to use this name, which is already registered in the DNS, as the domain name on the certificate. Because recall that when you request a certificate from Let's Encrypt should be able to call into your environment. And then it will call whatever the name is on the domain name is on the certificate, will call that in order to get into our environment and go through the challenge and response that we talked about. So in this case, I'm not going to register a new name. I'm just going to reuse this name. It's really convenient for this exercise. I don't need to create a new DNS name. And then we need to create a new firewall rule that allows traffic from port 80 into the Ingress controller. So that is the IP address of the Ingress controller. So when the request comes in, we need to allow it on port 80, and also we need to forward that to the Ingress controller. We'll install Cert-Manager, We'll then install a test application and a service that goes with it. We'll also then create a cluster issuer, so that will be issuing certificate on working with Cert-Manager will issue certificate for a client. And then we create a TLS Ingress. And then the TLS Ingress actually has a shim that will use the cluster issuer that we specify. And then through Cert-Manager, it will request a new certificate. And as we recall, Cert-Manager will also create a service, ACME resolver on the fly. And the Cert-Manager will call into our environment using the domain name that we use on certificate. Again, in this case, the name of my router. The request comes into the router, through the firewall, to the load balancer, through Ingress, and then ACME resolver will resolve that. And finally, the certificate will be issued. I'm connected to my router, and here we can define the firewall and forwarding rule. I'm using a Motorola router. Obviously, you might be using a different one. So in my case, I have to go to the advanced router forwarding. And then here you can define rules. So either for IPv4 or IPv6. So I've already defined the rule here. So local IP address and the port, this is when the traffic comes in, where should it forward it to? In our case, this is the IP address of the Ingress controller, and the port is 80. And then external IP address that is allowed. Here I specified 00000 because I don't know the IP address of all the IP addresses that belong to Let's Encrypt. So in this case, 00 means that all traffic is allowed. And then it also then specified what port the caller should be calling into. So that is port 80. And the protocol is TCP. So this is basically how traffic from Let's Encrypt will be forwarded internally. So the first thing that we want to do is install Cert-Manager, and we can install Cert-Manager from this location. I'll provide the script for you, so you don't have to worry about remembering where to get it from. So let's go ahead and run that. It takes a couple of seconds to install that. And then we want to make sure that all the pods that are associated with Cert-Manager are in run state, so kubectl get pods. And then it will create a namespace called Cert-Manager. So let's go ahead and take a look at it, and we'll see that all the pods are in run state, which is good. And then we can, and this part is optional, we can install a Cert-Manager kubectl plugin, so we can interact with Cert-Manager, and I'll show you this on line 12, we're going to use that. So let's go ahead and download that from this location. And then we can unzip it on line 9. And then just all it needs is copy it into /user/local/bin, so that will be available for us to use. And then on line 12, although we checked to ensure that all the pods running, we can do a more comprehensive check, and that is through the command that we just installed, kubectl cert-manager check API. So it's going to do some internal checking to ensure that all the services associated with Cert-Manager are running, and then we get the result that Cert-Manager API is ready, which is good news. Now that we have Cert-Manager installed, we can proceed to actually go ahead and next step is to create a sample application, to create a certificate issuer and create an ingress that will forward traffic to our service. So the first thing that I want to do is online, I'm going to create a variable that will hold the name of my domain name, which is on the certificate. It's a rather long name. So I'm just put it in the variable for convenience sake. And then on line 4, we're going to create a new test application, hello world, that we used earlier. And then we're going to create a service that is associated with that, and it's called my service. And the name of the service, let's go ahead and create that. That's done. Our next step is to create a certificate issuer. And so I've created one for the stage environment and one for production. So in the test environment, we're going to use the ACME-staging, and then for production, we're going to use actual ACME certificate. And then we went through this process before during the presentation, so I'm not going to spend too much time here. So let's go ahead and apply that. And we see that that is created. And line 11, kubectl get cluster issuer to verify that it's created, and we'll see that the status is ready. So let's clear that. Next is to create an ingress that will then forward the traffic to the service we just created. So let's take a look at our stage ingress. Again, I'm creating two ingresses, one for stage and one for production. So the stage uses the certificate from the Let's Encrypt staging server, and one production from the production environment. So I'm just going to call this TLS ingress stage. And then we need to here specify under annotation. First, we need to specify what ingress controller is being used, and also the issuer, which is the one we just created earlier over here. So that's the name of our Let's Encrypt stage. So that would be the issuer. And their TLS and the host. So we have the host name, which is again corresponds to the name of my router. And then below that, then we specify the same thing and their host here. And then the name, the service that it's forwarding to is my service we just created. So let's go ahead and apply that. And so that's created. Now we can verify that on line 17, kubectl get ingress. And this is the name of the ingress that is created. And sometimes you may see two of this, so there's another one. And so the other one would be the temporary ingress that Cert-Manager creates in order to set up that service to respond to the challenge. But it happens very quickly, you may not see it. If there's an issue, you probably, with your environment, then you might see it longer than a few seconds, because it's trying again for, waiting for the Let's Encrypt to call into it. And if Let's Encrypt has problems coming into your environment, then it won't be able to issue the certificate. And line 20, we can then now verify. As we mentioned, as part of the ingress, it also, the shim, which is associated with the ingress controller, will also request a certificate. And we can verify that on line 20. kubectl gets a certificate and -OY. So, and we'll see that this certificate, this is the name of the secrets that is associated, the issuer, and also the status. So the status should say that certificate is up to date and has not expired. If there's any other message here, it means that there's something wrong with the environment and Let's Encrypt was not able to connect to your domain. And I've included a page which is really good for troubleshooting from Cert-Manager. We can go through that. So the biggest thing, again, is to ensure that Let's Encrypt will be able to call into your environment through the DNS name. So the port 80 has to be open. Okay, let's just clear this. Now that we have the certificate, we can also then connect to the certificate and get some information about it. So on line 23, open SSL s-client. So you need to install OpenSSL first if you haven't installed in your environment. Again, this is just for your information, it's not required. So OpenSSL s-client-connect, and then this is the DNS name for my certificate, and then on port 443. Let's go ahead and run that, and we get some information about the certificate. Let's scroll up. There's a lot of information you can view. This is the actual certificate that was created, and also here it shows you the CN, that is the name on the certificate. So that corresponds to the domain name. And also the issuer is Let's Encrypt. Let's go ahead and exit this. And now on line 25, we can actually now test our service, our ingress. So curl -k. So -k means that don't validate the certificate. And the reason for this is because this certificate was issued by the staging and by Let's Encrypt staging. This is not valid as far as the browser and also the operating system is concerned. That certificate is not valid. So we need to switch it for -k. When we move to the production environment, then we don't need to do this. This is for the test environment. So let's go ahead and run that. So HTTPS, so we use HTTPS and the domain name, and then that basically forwards a request to our service, and this is a response back. Okay, so that's just how we can set up Cert-Manager, and then create an issuer, create a application, a service, Ingress, and how we test that. So let's go ahead and delete this test or issuer and the Ingress for the stage environment, and then next we're going through and do the same thing for the production environment. We've reached the end of this video, and we certainly covered a lot of stuff. I hope you enjoyed it and learned something. Thank you.